Our topic is water management in Singapore. We have restricted ourselves to the material provided for this assignment, the case study about water management and the Straits Times article about flooding in Singapore. We understand that these articles were written many years ago and the situation currently might be different from what is described in them, but for the purpose of the assignment, we have decided to base our answers on the articles provided. As of now, Singapore buys untreated water from Malaysia for domestic consumption and sells treated water back to Malaysia. But the regulation that binds Singapore and Malaysia into this agreement will expire in 2061, and if it does, it puts Singapore at a risk. Given this background, our group will look into water management in Singapore. Our group has identified the following as the mission, vision and goal for water management in Singapore. The mission here is to increase water security and self-sufficiency for Singapore, to overcome dependence on Malaysia. The vision is to provide long-term water security beyond 2061. The goal is to efficiently manage water in Singapore through a holistic approach to achieve water security and self-sufficiency. Many different stakeholders are involved in water management in Singapore. These are United Nations, Singapore, Malaysia, PUB, domestic consumers, commercial consumers, partners such as contractors and government agencies such as URA. Some of these stakeholders have a bigger influence on how water is managed than the others. Two stakeholders with the highest level of influence are Singapore and PUB, followed by government agencies that PUB closely works with and ultimately the rest of the stakeholders. When it comes to water management in Singapore, there are a lot of different stakeholders, each with their own interests. First is the United Nations. UN focuses on a wide range of fundamental issues including sustainability, well-being of the people and international peace. As demonstrated by its Millennium Development Goals, it is in UN's interest to push countries towards ensuring sustainable access to safe drinking water for the people. It is also in UN's interest that the issues between Singapore and Malaysia on the water agreement don't escalate into a conflict and are in fact, resolved amicably. Next is Singapore. As a tiny island state with very limited resources, it is heavily reliant on other countries for most of its needs. For something as essential as water, Singapore is interested in ensure long-term water security. Next, Malaysia. The overall relationship between Singapore and Malaysia when the agreement was signed in 1961 is different from what it is now. The price at which Singapore was buying the water was set back in 1961. As a supplier, Malaysia now wants the agreement to be revised to reflect today's standards so that it obtains a fair price for the water that it is selling to Singapore. One of the most important stakeholders of water management in Singapore is the PUB, Public Utilities Board. The PUB regulates and oversees the country's entire water supply system, which comprises the water catchment systems, drainage systems, waterworks, water reclamation plants and sewage systems. To summarize, PUB is interested in managing the water cycle and related infrastructure of Singapore. One set of stakeholders are the end users of this water. Our group has classified them into two categories. First category consists of the domestic consumers who are interested in receiving a potable water coupled with high level of service and low price. Second category consists of the commercial consumers who are interested in receiving industrial standard water coupled with high level of service and low price. The last set of stakeholders are the organizations that are involved in water management in Singapore. These can be classified into two categories. First category consists of the profit-seeking partners such as agencies involved in research and development, contractors that carry out infrastructure development works, etc. The second category consists of government agencies such as SLA, URA etc. who are not interested in profit but in efficient and sustainable urban planning in Singapore. All the stakeholders can be classified into a 2x2 matrix based on their power versus interest in water management in Singapore. The key decision makers whose decisions affect the demand or supply or infrastructure related to water in Singapore are considered stakeholders with high power. These are Singapore, PUB, the relevant government agencies and Malaysia. Water management is clearly of high interest for Singapore and PUB. It is also of high interest for Malaysia since it supplies the water to Singapore and earns money through it, and if Singapore were to become self-sufficient, this would have financial and geopolitical impact on the relationship between the two countries. Since the government agencies like SLA, URA are not primarily tasked with water management, this is a relatively low interest for them. The rest of the stakeholders have limited power when it comes to how water is managed in Singapore. but it is definitely of high interest for the domestic consumers as a source of life and for commercial consumers for their business activities. Similarly, United Nations is also very interested in water management in Singapore due to the reasons mentioned previously. On the other hand, profit-driven entities like contractors and bodies that assist PUB with R&D activities are primarily interested in profit-making and not in water management as such, hence they are placed in the bottom left quadrant. Coming to the boundaries. Firstly, let's look at the internal system boundary of the water management system. Water is treasured resource, so as PUB's capital funding which is used to finance the system. PUB, as the main stakeholder, regulates and oversees the country's entire water system through a holistic approach by expanding the water source and supply, while managing the demands and consumers. The concept of operations chart illustrates the water cycle. In one path, the water transits across the natural hydrosphere, from sea to rain, to the surface, to the underground, and return to the sea. The water cycle also consists of the paths shaped by human activities, in the territory of Singapore. The water may flow into 17 reservoirs, transmits through 8 water treatment plants and distribute to domestic households, then become wastewater to be collected via drainage and sewage systems, and reclaimed in 5 new water factories, further distributed to the industrial and commercial buildings. The seawater may be sucked into 3 desalination plants and be treated before distributed to household and industrial buildings. Externally, we classify the boundary into PESEL types and apply SWOT analysis. Political-wise, the system has solid support from government, to eliminate the risk from sovereign interest of Malaysia. It is an exemplary integrated system following the UN's guideline and objectives to ensure that every resident has access to clean drinking water and proper sanitation. Through legislation and legal framework, the government has authorized PUB the autonomy to manage the system. Socially, the system has gained public support through community-driven, public education and awareness programs. Technologically, we are at a good time of mature technology, such as water treatment, desalination and reclamation. Continuing collaboration among water community and partners is the key opportunity into the future self-sufficiency. Local strong economy and relatively high income are also playing a role of strengthening the system. The above-mentioned external factors are supporting the system and are opportunities to maintain and continuing improvement. Meanwhile, the system also faces its weakness and threats. The sovereignty interest conflict with Malaysia is one. The inherent water resource scarcity is another. The completed and ongoing infrastructure and construction, the durability and reliability requires continuous monitoring and maintenance. A sustainable engineering talents pipeline attributes to the long-term stability of the water management system. And PUB has set up Consultants Private Limited Company and wants to export its expertise. However, in Singapore's context there is no much experience on farming and agricultural water management, and even larger-scale network of infrastructure in terms of city size and complexity. Speaking of environmental and ecological concerns, the human intervention to the hydrosphere, which may or may not impact to the regional and local climate and weather, requires extensive and inclusive study and research. And to cope with global warming and extreme events, such as drought and flooding, PUB needs to develop and maintain a broader approach for land protection. The growing population and demands is controllable through various governmental efforts. Lastly and unpredictably, the political and public support may turn the other way in the events of future change. Water management system is a large-scale system with various complexities as summarized below. The system encompasses various structural, behavioral and dynamic complexities. We will see the details of all the individual complexities in upcoming slides. With a total area of 700 square kilometers and with a population of 5.612 million, Singapore consumes about 1.36 billion liters of water per day. With an average consumption of 19.3 cubic meters per household in 2004, the average monthly bill per household is $29.4. On a national scale this would amount to 62 million only for domestic consumption excluding industrial usage. This complex system is also bound by critical timelines such as the need to achieve self-sufficiency and long-term water security beyond 2061. Furthermore, the system is also emergent and unpredictable as a lot of research and technologies are still under implementation and review stages. With a large stakeholder network, the water management system is scattered all over and beyond the island with its extensive network of pipelines and drain facilities. The large number of components involved, such as aqueducts, shipments and treatment plants, this network requires a lot of interconnections. For instance, the water collected by various reservoirs across island undergoes rigorous process of treatment at few PUB plants. Part of the seawaters are also processed at desalination plants. The treated waters are then transported to households and industries with an extensive transmission network of about 5.5 kilometers. The new water treatment system complements above with its 3.5 kilometers network. Therefore, the system has intricate connections at various levels. Further to the above interconnections, human factors and other external influences such as political atmosphere makes the relationship between demand and supply even more intricate. Evolving transportation and treatment technologies adds to the structural complexity of this system and impacts the cost and quality of operations. For instance, in late 2005, the 2S desalination plant was opened at a cost of $119 million. This used reverse osmosis process to treat the water. Singapore claims wastewater after secondary treatment by means of advanced dual-membrane technologies, what is popularly called the new water today. Too many stakeholders mean diverse needs. At times this may lead to conflicting interests as well. This is probably a key behavioral complexity for most systems or projects. Surprisingly, PUB has managed this quite well over the years. With a solid political and public support, PUB has increased the water tariffs. This has helped Singapore reduce the average monthly household demand and consumption. However, few social media posts and public blogs have shared some negative criticism in recent years. Another behavioral complexity is the political atmosphere and relationship between Malaysia and Singapore. The current agreements create uncertainty on the future of Singapore's water security. The success of the long-term treaty to continue the water transfer from Johor at affordable rates is highly influenced by the ongoing state of affairs that may influence the decisions. For instance, the recent calling off of high-speed rails initiative between Singapore and Malaysia following political changes and different priorities set by the new government. Apart from too many stakeholders and political influences, some of the recent technologies were also faced with behavioral challenges. One such example is people's acceptance to new water and their concerns on the reliability and long-term health impacts with the usage of this system. Therefore, the water management system needs to actively consider public expectations and shape their mental models over time to accept new water as their preferred choice. Forcing public to use such technologies when public is not ready to accept may create negative publicity and may affect the integrity of the system in long run. Thus, it can be seen that the boundaries are not easily recognized and requires a level of uncertainty and retrospective analysis. The pricing mechanism and changes in tariffs are some examples of the dynamic nature of the system that evolves over time. Such checks and balances at different levels have proved very effective for PUB over past years in controlling consumption. However, it is not a sustainable solution to keep increasing the pricing as it may deprive the low-income communities of a proper access to water. Thus, it creates a need for the system to adapt and manage the dynamics with suitable policy interventions from time to time. Another dynamic complexity is the pace of technologies and emerging trends. This influences cost, service efficiency and pricing models of water management system. Consistent growth and sustainable technologies are key to ensure Singapore meets its goals of water security and self-sufficiency by 2061. Climate changes is also a dynamic complexity influencing the daily operations of a system. Heavy rains and flooding at different parts of Singapore has increased awareness and pressurized government to provide better water collection systems to manage flooding. Uncertainty of water supply from Malaysia beyond 2061 due to changes in requirements due to geopolitical events is also a dynamic complexity. Thus, the water management system falls in the right uppermost corner of the complexity table. It exhibits properties of a complex system defined by Sinfen framework. Thus, the system requires a large-scale system engineering framework for an efficient functioning. There are a few areas in which Singapore has taken steps to manage its water system to achieve its goals. These areas include system governance, supply and demand management, wastewater and drainage water management, which we will identify and evaluate. Governance of the water system in Singapore is profoundly impacted by the Government of Singapore and its water agency PUB. Here, we start off by looking at how the Singapore government has taken steps to provide an enabling environment for the water system. Immediately after separation from the Malaysia Federation, the Government of Singapore has made water security one of its highest priorities. Despite this, the government has taken conscious steps to unilaterally develop water institution with other developmental sectors, as it knows different systems can affect and impact each other and we are only as strong as our weakest link. The Singapore government also provides its water agency strong political and public support. An example of political support is the approval for PUB to issue bond investment to public to further self-sustain their water business. The government also helped rally for public support, so PUB can discharge their policies effectively, especially the implementation of progressive water tariffs to lessen demand. The government has also taken steps to make PUB autonomous, hence giving them more authority to manage the entire public water system, and provided a top-down clean governance policy to curb all forms of corruption on a high level. All these steps taken will provide PUB with an enabling environment to manage the water system. PUB, on the other hand, has taken various steps to manage the water system via internal processes such as having an effective legal and regulatory framework, keeping an experienced and motivated workforce, and the use of private sector to gain special competence or competitive advantage to lower costs. These steps are introduced to provide PUB with the institutional effectiveness to manage the water system. Apart from governance, steps are also taken in supply and demand management to ensure effectiveness of the water system. To ensure supply of water, we have to protect our water quantity. This is done through water agreement with Malaysia, protection of water catchment or facilities with demarcation and barriers, and building of water treatment plants. The protection of water quality is done through the Trade Effluent Regulation, which prohibits pollution into water catchment. To further ensure reliable supply of water in the system, investment and expansion of water sources and desalination, wastewater reuse and storm water collection are put in place. Through R&D, technological development is also used to increase water availability, improve water quality management and lowering production and management costs. Lastly, steps are also taken to ensure there is no illegal connection to our water supply system so as to keep unaccounted for water to the minimum. Steps taken to manage demand in the system includes the use of a progressive tariff structure. A combination of water conservation tax, waterborne fee and sanitary application fee are used to lower demand of water to a sustainable level. This is important to management the water system as it moderates the water load for sustainability. Household also has a higher financial disincentive for water consumption as they are the largest consumer and has the strictest quality requirements. As part of the Millennium Development Goals set forth by the UN, sanitation and wastewater have to be collected, treated and disposed of in an environmentally sound manner. To meet this, a fully connected but separate drainage and sewerage system was built to facilitate the collection and reuse of such water. New water technology has enabled us to reuse these water collected for domestic and commercial usage. However, due to the stigma of recycled water, community-driven awareness programs are conducted to change public's mindset of consuming water derived from waste. Ultra-pure quality new water has also been developed for industrial and commercial customer. The steps taken allowed for proper sanitation as well as reduced load on other supply sources in our water system to keep it sustainable. Due to the impact of climate change, countries including Singapore are facing more erratic rain patterns which may contribute to flooding. Steps taken to reduce impact include the construction of storm surge or flood barriers and the expansion of underground networks of canals and other storage or drainage infrastructure. Mandatory flood protection measures are also put in place for new development and redevelopment projects. People are provided with information on what they should and should not do during flood through continuous education and awareness programs to increase their preparedness and resilience. Sensors and other continuous water level monitor alert systems are also installed. Continuous improvement projects such as widening and deepening of drains are also implemented to flood-prone areas. Each step taken has an intention to impact the system. However, some might have unintended consequences. Some unintended consequences that arose from steps taken in governance of the system includes PUB being top 5% in terms of performance quality, Singaporeans taking free flow of clean water for granted, meeting UN goals, PUB having surplus money for investment and relationship ambiguity with Malaysia. Unintended consequences that arise from our supply and demands measures include strained relationship with Malaysia due to water agreement stalemate and water being expensive for low-income group due to the introduction of tariff system to curb demand. These resulted in the government pouring in subsidy or rebates for the poorer group to help offset their financial burden. Lastly, some unintended consequences that resulted from our wastewater management is that Singapore has become a tech leader in reclaiming wastewater, and this has helped us improve relationships globally by sharing our knowledge and new water technology to other water-scarce nations. The local measures of reducing speed of rainwater into public drainage to prevent flooding has also allowed attractive green roofs and rain garden concepts of our urban development. Thank you.